All right. Looks like it is working. It says we're live here, so good stuff. Okay, so welcome everybody to the Open Ag Learning Series. This is our first real session. I am Dan Kane. I work at Michigan State University, but had the good fortune to meet all these folks out in California. That kind of was the place where this group sort of formed and got going. And we decided to do this learning series. It should be a lot of fun. So this first one is going to be done by Mark Easter out of Colorado State. He's going to be talking about Comet Farm, and I'll let him introduce himself some more. But also let's Dorn Cox, and it looks like Abe, you just hopped on as well. If you guys want to do introductions real quick as well for yourselves.
Sure, I'll go. So Dorn Cox, I'm calling from Durham, New Hampshire, near the University of New Hampshire, and I'm affiliated with this group through projects, the Farm Hack Project, an open source repository for farm technology, as well as the Farm OS collaborative record-keeping system for farms. Also built as an open source platform to facilitate knowledge exchange. So, and super excited to get this series going and start the collaborative process. The other sort of quick update for this group is I will be going to Ardmore, Oklahoma again in 2 weeks to follow up on the measurement team for the Soil Renaissance project. So I'm looking forward to bringing this series and our discussions to that group, and hopefully bringing them, closing some of the loops here.
Abe Collins, I'm a cattle grazer, and I've met everybody here, but working on a number of sense landscape and cattle grazing and soil and water quality projects.
Amanda mentioned her audio isn't working, so we'll have to...
Next time.
Next time, Amanda.
Sure. And I guess before Mark jumps in, Kevin Watt, you're here as well, if you'd like to introduce yourself a little.
Hi, everybody. So I'm Kevin with Tomcat Ranch here in Pescadero. I work with Wendy Millett and also have my own smaller operation that does pastured poultry and hogs. So we run the whole gambit here.
Great.
Fantastic.
Right. Well, with that, I think we'll perhaps jump into the presentation. Mark, if you want to take it away. And folks who are just watching rather than on the actual call, the structure is going to be basically Mark's going to talk for a while and give us some fodder for things to think about and talk about, and then we'll begin to have a conversation. And folks who are just watching, you should be able to utilize, there's a question and answer app on the event page where you're watching. Please put any questions as you're going along in that, and Mark will be able to get to them towards the end. And with that, Mark, go ahead and take it away.
Things kind of froze up, and I think we might have lost Daniel, but I'll just go ahead here on the assumption that things are still working. My name's Mark Easter. I'm an ecologist here at Colorado State University. I work at an organization called the Natural Resources Ecology Lab. We are a soft money research institution here, part of the Warner College of Natural Resources. The organization was founded in the early 1970s. And we've been involved in developing greenhouse gas inventory methods and decision support tools associated with greenhouse gas inventory methods for basically about the last 20 years. The Comet tools have gone through quite an evolution, and that they've really started in about the year 2000, and I'll have a timeline to talk with you about that. Our research group is led by Dr. Keith Postgen, a professor of soil and crop sciences here and a senior research scientist at NREL. And then Kevin Brown is leads the software development team for the graphical user interface and all of the calculations. So, let's see here. So here's a brief outline of the presentation. I've got 19 slides to go through, and then I'll give you a quick demo. So I'm going to walk first through what is Comet Farm, and talk about the need for tools to allow growers and natural resource specialists, agency personnel to be able to assess greenhouse gas emissions from ag practices. Give you a historical timeline of the tools, and then talk about some of the details, and we'll follow that up with a brief demo. Comet Farm is designed as a web-based, full farm-level and ranch-level greenhouse gas accounting tool. It's designed to be able to assess the full scope of emissions associated with greenhouse gases. And shown on this page here, we have this diagram here that is a sort of an overall summary of what the different greenhouse gas emissions are associated with agricultural practices. This was prepared by my colleague Amy Swan here at NREL for the IPCC. And what this is really intended to show is that virtually every practice associated with managing a farm or a ranch or a forest has some consequences for the environment in the context of greenhouse gases. There's lots of other interactions as well too, but there's a constant gaseous exchange that's going on between soils, plants, and the atmosphere. In some periods during the growing season, when it's moist enough, plants will be taking up carbon dioxide from the atmosphere. At the same time, there's decomposition that occurs, and carbon dioxide will come from soils and decaying plant matter back into the atmosphere. Similar with other sorts of processes that lead to nitrous oxide emissions from various sorts of farming practices, whether that's the application of fertilizer or management of livestock, nitrous oxide coming from livestock manure. Some of the big emissions associated with agriculture also come as methane from livestock in the form of enteric methane from ruminants like cattle, and also methane that comes from production of rice. And so there's a whole suite of these things, and there's a lot of interactions between different farm practices that can produce these emissions. What we've tried to do in Comet Farm is to develop a single tool that allows users to enter information, details on their practices in a straightforward, simple way that can then cut across all of these different interactions and give them a full picture of what the total greenhouse gas balance of their operations are. I'm showing here the Keeling curve, and this is just to express what the basis for this work is, and this may now be the most famous scientific graph in history, and just to express what some of the urgency is around this issue with carbon dioxide emissions in the atmosphere climbing. This was from June of 2013, and we're now above 400 at this point for the first time in history. I should say in human history. And just to explain a little bit more about why this is important, I'm showing you a slide here from the US EPA's greenhouse gas inventory, showing that carbon dioxide is 84% of the total emissions, and nitrous oxide is 5%. And total emissions coming directly from agriculture are about 8%. So why is this important? First of all, photosynthesis is still, as far as we know, the best way to remove carbon dioxide from the atmosphere, and agriculture has a pretty significant role to play there. And also there's a pretty significant nexus between agriculture and nitrous oxide emissions here, which where agriculture has a significant role to play in reducing nitrous oxide emissions, especially since the majority of the emissions N2O emissions come from agricultural practices. agriculture has one of the largest near-term mitigation potentials for mitigating greenhouse gases and climate change. And there are a number of proven technologies that are ongoing, and there's a lot of farmers who are already instituting practices that that can help mitigate the problem, help sequester carbon in soils and plant matter, and also reduce methane and nitrous oxide emissions. But unfortunately, the inclusion of agriculture has lagged significantly within international greenhouse gas mitigation policies and voluntary offset markets here in the U.S. That's starting to change, but it's a good question why. We think probably the biggest issue has been that there has been a lack of confidence in the capability to quantify, verify, and administer greenhouse gas mitigation activities. Emissions and carbon sinks are dispersed. They're non-point source. Additionally, direct measurement requires specialized equipment and training. It's generally too expensive for a person to go out and just measure the emissions coming off their property or their practices. And there's a lot of local scale variability. Climate and soil conditions interact to produce variability in how their practices respond to actual management. Farm level management really matters. In addition to that, there's been an absence of incentives. Funding carbon credits is expensive, and it's been risky. It's becoming less risky as we start to understand the emissions better and improve the ways we go about assessing what the emissions are. But still, they require validation, verification, and a certain degree of confidence. Additionally, legislators and regulators have been reluctant to move forward. Although that's changing in the state of California, and appears like other parts of the country and the world are starting to line up behind either legislative or regulatory response. So there have been a number of different efforts out there to try and help assess this, ranging in scale from very basically static approaches, empirical models, represented by like the IPCC, for example, that address relatively few source categories and are and low level of integration, and all the way up to, at the far end of the scale here, combination of dynamic and static based models, which we use in Comet Farm, which attempt to do a full integration of all greenhouse gas or all practices on a farm or a ranch associated with greenhouse gas emissions. And there's probably some that I've missed on this in this slide, but this gives you a picture of what a lot of the different practices or different attempts have been made to do prepare tools like this, like Comet Farm. Just to give you a quick timeline on the Comet tools, the effort really started in 1988 before we formalized our work here with the IPCC. In 1992, the U.S. signed the UN Framework Convention on Climate Change and agreed to start reporting country-level greenhouse gas emissions. And there's also a bill called the Energy Policy Act of 1992, which President Bush signed, which had a section on voluntary reporting of greenhouse gas emissions. And the Comet, the effort to start to build the Comet tools came out of that need for a voluntary reporting tool. In '96, the IPCC released its first major report recommending guidelines for greenhouse gas inventories. And then in 2000, we began a collaboration with the NRCS to build a tool to support the voluntary reporting under the 1605B. We initially began building tools that ran the Century model for states for Iowa, Nebraska, Indiana, and Illinois, assessing the dominant crops and dominant practices in those regions. In 2005, we moved the tool that we'd been building onto the web, and we called it Comet VR. And it assessed the dominant practices for crops grown throughout the lower 48 and cover about 85% of cropland to assess the carbon and nitrogen balance on those lands. In 2009, we released Comet 2.0, and it was designed to improve assessment of nitrous oxide emissions. We also added orchards, vineyards, agroforestry, and an energy assessment tool, and some assessments of uncertainty. In 2013, Secretary Vilsack released Comet Farm, and the new features of the tool at that time where we shifted from the century to the day-cent model, which allows a more accurate assessment of trace gas emissions, particularly nitrous oxide from fertilizers and methane from rice production. We also shifted to a year-by-year management descriptions, added an animal agriculture component, and further improved our uncertainty estimates in the tool. Comet Farm improvements that we're working on as we speak and hope to have in before the end of June are to add an improved agroforestry, orchard, and vineyard assessments. We have actually a wetland rice component, which we've just recently added, and yet further improvements in uncertainty assessment. I just want to give you all our take on what the attributes of an effective quantification system would be. We think probably the most important is acceptable accuracy and precision with quantified uncertainty. There's a trade-off between accuracy, precision, and uncertainty. And that trade-off has to do with the amount of information that users are able to enter into a tool in order to be able to drive the model. The more information we have, the better, the more accurate, and the less of an error term or error bar there is around the results that come out of it. But there's sort of, it can create an onerous burden on a user to have to provide too much information. It can become a roadblock for some users. So we've been striving for a decade and a half now to understand what that sort of sweet spot is in terms of the amount of information that users can provide, and where that trade-off is between how much time they need to invest in data entry versus the actual results that come out of the model. So we also think that tools should be applicable for the entire US, but be locally specific. There needs to be a certain amount of flexibility to be able to incorporate a range of conservation and mitigation practices. Full greenhouse gas accounting is critical because there can be trade-offs between, for example, you can try to increase plant production and improve soil carbon sequestration at the expense of increased nitrous oxide emissions from fertilizers. So we need to be careful about that sort of thing. We also think it's important that the results lead to an equitable solution for producers, so that producers have the opportunity to be compensated for what they produce in terms of mitigation efforts. The tools we produce, we want to be cost effective, and we want it to be consistent across different spatial scales. So with that, with those in mind, our aim is to allow non-greenhouse gas specialists to easily estimate farm-scale greenhouse gas emissions, to explore what the impacts of alternative management and conservation actions might be on improving their greenhouse gas balance. We want to employ state-of-the-art methods and models, make them directly accessible to the public, and provide rigorous estimates of uncertainty. So we've been able to achieve a lot of this. We do have a full farm level service. It's web-based, and it's has the capability for users to come in, register their name. We fully protect our or not, I'm sorry, not their name, but register their email address, and that allows them to store data. We fully protect that data. It's not available to any person except themselves. It's fully free, open to the public. Anybody can come in and use it. Provides a spatial user interface for people to map their farms and practices, and then incorporates the existing NRCS USDA products, including the Web Soil Survey, their energy use tool, the U.S. Forest Service FIA, and then also, I don't have this in here, but we're incorporating the USDA approved methods document. That's essentially the inventory methods that have been peer reviewed for USDA for greenhouse gas inventories. So how does the tool work? Users first enter their location, and based on that, either a point or a polygon that they draw for a field, we pull in information on climate and soils, historic rotations, and equation factors for the models. The user then enters some specific information on their farm level activities. We then run models here beyond that to generate results for the user, and I'll give you a demo of this. The key data sources behind the tool are the NRCS Sergo database for soils. We use a climate data set called the North American Regional Reanalysis. For land use and management, we use information from the National Resources Inventory, which is a point-based sample of land use and land cover around the country. It's updated yearly. We use the ERS Cropping Practices Survey, NRCS details on manure management, and information from EPA on fertilizer. And then a series of surveys we did called Carbon Sequestration Rural Appraisals. And then along with that, user input of detailed management practices for the last decade to decade and a half, and then for their projected practices into the future. For data entry and the cropland module, we ask people to enter, in a general sense, what the historic management has been. We ask them to provide details on cropping sequence and approximate planning, harvest date, tillage, the rate, timing, type, and application method for fertilizer and manure applications, that sort of thing, and then how residue is managed. Then for livestock, we ask people to describe their herd size and composition, how they manage their manure, and what their feed characteristics and supplements are. And then for the energy module, we draw from information entered into their field and livestock modules, and then provide additional info on capital equipment and on-farm renewable energy production to calculate their energy balance. The calculation methods are drawn from, I guess I do have this in here, drawn from this document, the quantifying greenhouse gas fluxes in agriculture and forestry, methods for entity scale inventory. We call this the Blue Book or the methods document. It's been peer reviewed, developed by the USDA, and is sanctioned by that agency for assessing soil-related greenhouse gas emissions, as well as from livestock, energy-related emissions, and then uncertainty estimation. So just a quick update on upcoming efforts. We're adding a drought mitigation component to the tool. We're also working on fully integrating pasture and rangeland, essentially allowing users to fully integrate a livestock operation into their systems, especially where there is a pasture interaction with, say, for example, grazing on corn stubble or grazing on a winter wheat pasture, this sort of thing. We're also adding back in details on agroforestry and perennial crops using updated models provided by the Forest Service through the FIA program. And with that, I'm going to skip the last slide here, and I think we'll go straight to demonstration here. So I'm going to make a quick change here. If you all will bear with me for a second, and I'm going to switch to a different slide that I have. Okay, you now all should be able to see the Comet Farm browser that we have here. So this is what Comet Farm looks like when you first come into it. The URL is cometfarm.nrel.colostate.edu. That's cometfarm.nrel.colostate.edu. The first thing you'll see is this browser right here. You can watch this introductory video. I'm going to skip it now, but I encourage you to look at it if you haven't been there. It gives you a quick summary of the tool's capabilities. This is our splash page, and I'm just going to take us straight to using the Comet Farm tool, but you can also go straight to our quick energy tool here. So it gives you the option to either continue without registration, or to log in as a user. And if you'd like to store information about your projects and practices, I encourage you to go ahead and register your name and provide a password that only you will have access to store that information. This way you'll be able to come back to the projects you have. You can continue without registration. There's no restrictions on that. You can go forward. You just won't be able to record the information you enter to come back and use it at a later time. So the first thing you see here is a list of all your existing projects on the left-hand side, and then an opportunity here to define a combination of cropland, livestock, agroforestry systems that you may have on your farm. I'm going to create a new project, and well, it's not going to let me do that. So I'm going to go ahead and just use the one I have right now. It's just as an example here. So this is an example from southwest Kansas, and this is a continuous corn system that's growing in this area here. And what I think I'm going to do here is actually I'll go ahead and use this. So the way the tool works, the very first thing you do is you come in and you define where you're farming, either with a parcel or with a point. So on the left-hand side here, you probably see this looks a lot like Google Maps, and it's because it's running Google Maps in the background using open layers. So you can add a parcel by point by clicking on Add Parcel by Point, and then you can click, for example, in the center of a point or a center of a field, and let's say that's 123 acres, and save that. Just created a point. I'm going to go ahead and delete that and just show you how we can add a parcel. You could just, let's say we wanted to analyze this pivot here. I'll click on this Modify Parcel. Add Parcel by Polygon. So you can just start drawing in your circle here. So I've just created this other circle. Now that's really for demonstration purposes. I'm going to go ahead and delete that. And we'll continue to work with this field we've identified here. So I'll click on this I am done defining parcels. And the first piece of information that we ask for is what was the historic management. This is important for understanding how crops are managed, or how crops have been managed, and is important for understanding what soil carbon stocks are now. The soil carbon stocks on a farm today are really dependent on practices that go back up to a century or more in terms of plow out and the types of crops that were grown, intensity of tillage, and that sort of thing. So we've defined this as a lowland, non-irrigated parcel before the 1980s, and it was never enrolled in the CRP program. We're saying in 1980 to 2000, it became an irrigated winter wheat milo corn system, and then the tillage, we identified it as reduced tillage for this parcel. So this gives you a sense for the type of information that needs to be entered in order to, if you will, spin up the model to about the year 2000. These information here are based on surveys that we've done, and also information from the NRCS Cropping Practices Survey. So I'm now going on to our detailed page management. So the first thing we do at this point is we try to describe what the cropping practices are in the year for from 2000 to present. What I'm going to do is describe a continuous corn system that's conventionally grown, and then we'll run an analysis where we convert that to a different type of, we'll essentially impose a conservation practice upon that. So we have a corn crop here that was planted on May 2nd of the year 2000. The harvest date is October 31st of 2000. They harvested grain at approximately 200 bushels per acre, and they're removing approximately 20% of the stover. So the next detail that we add here is we describe what the tillage practice is. And so we're going to say we continued with reduced tillage from as was done before, and the tillage was done largely in the spring. And then we describe what the fertilizer additions are. And so we have a split application of fertilizer, where in May the grower applied anhydrous ammonia at 40 pounds per acre, and then in 45 days later applied a UAN application at 160 pounds per acre. We also give the user the opportunity to show a manure application if they're using manure. I'm just, for sake of simplicity, I'm leaving this off for now, but this has the potential to significantly improve the green balance of projects, and we can add that as a conservation scenario. The next we add details on irrigation, and then finally if there was any liming or if crops or pasture rangeland were burned. So when this is done, the user, and I'm going to change this a little bit. Oops. Sorry. So you can't see this on this button, but what this says is no, we're not going to add an additional crop for the same year. That's in case you are following up with winter wheat or with a cover crop. In the scenario where you're continuous cropping, you have the option to say, okay, I'm just going to, how I manage my crop in 2000 is the same for the entire period up through the present year. So I'm just going to copy what I did in that time period to all the years that follow. And so I've just created a continuous corn conventionally managed system here Now I can go through and make further edits if I'd like. At this point, if I was running a crop rotation, you could add additional crops into the rotation here, such as soybeans and wheat are relatively commonly added, but just for simplicity's sake, I'll just leave this as continuous corn. And then we're going to go on to continue to future management. Now, what we did before when we originally set this up is we set up a number of different scenarios here. I'm going to, I'll just demonstrate what these are, talk you through them. We've got different types of stover removal scenarios where we're taking 30% off, 60% of stover, and then 60% plus some additional nitrogen fertilizer, and then a conversion to no-till. And we'll actually add another scenario to this where we'll just do no stover removal and convert to no-till, just for an example. So what the system did before is it copied over what we had entered under our current management into this future management scenario, and then we have the opportunity to step through each of these different management details up here and make changes to those as applicable. But I'm going to just walk through to the end of this first one, and then we'll go ahead and add another scenario. And I'll show you how that's done. And I'm just going to select from the baseline. So we just created this new scenario that you see here. And I'm just going to select for this first year of corn, I'm just going to go into tillage and change this to no-till. Leave everything else the same. And I'll copy these all to the following years. And now we're going to continue on to the report. So at this point, the tool is running the descent model in the background for all of the different scenarios that exist for this project. You can see it gives you the status up here. It takes up to a minute or so to complete everything. And now we have our report. I'm going to expand this out. So the first thing that you see in this column right here is the baseline. And this is essentially what we call the business as usual. If the user had just continued to run what they were doing before, this is how the greenhouse gas balance would be. And so for that 120-acre field, their net emissions would be about 31 metric tons of carbon dioxide equivalents. And then under the different scenarios that we ran here, I'm just going to take us to the conversion to no-till scenario here. We see here that relative to the emissions of 31 metric tons as carbon dioxide equivalents total here, we actually have a net greenhouse gas mitigation potential of about 63 metric tons. And that means we have a net sequestration by converting to no-till on this system. And what that consists of is a net carbon sequestration here of 56 tons total more than achieved under the baseline. And then also a net reduction in nitrous oxide emissions that we see right here, totaling up to a net improvement in about 63 tons. Now this is on a per year basis, so green is good, and a negative value means good. That's relative to the atmosphere, so it means we have a net reduction in greenhouse gas emissions compared to the baseline. That concludes the demo here, and I think we've got some time here for some questions and discussion, and so I'd like to hand it back over to Daniel and ask if there's any questions or comments. Take it away, Daniel.
Sure. Thank you, Mark. That was great. It was really nice to see that in action. I'm going to keep my video off here just to not take up too much bandwidth. But yeah, we'll jump into questions real quick. But before we did that, I wanted to ask you just two quick questions that are kind of our guiding questions we're trying to use for presenters. And I think you probably touched on these throughout the presentation, but to get maybe a more direct response would be nice. But first being, what are the barriers that you face, and how might collaboration with this group or other folks within this network, how might that help collaboration with those folks? And then in particular, how do you envision your tool helping farmers to improve regenerative agriculture in their operations?
Yeah. So those are great questions. And so addressing, first of all, how this group can help, what we find in the 15 years that we've been working on tools like this, we find it's that the innovators who are really driving the process forward. It's people like yourselves who have an interest in this and who are trying to achieve some level of greenhouse gas mitigation in their own practices, and trying to stimulate similar sorts of management improvements on their farms and ranches to stimulate their neighbors and other collaborators to do the same. And so how this group can help, come in and use the tool and give us feedback about how we can improve it from your standpoint, from the standpoint of the actual practices that you're doing, so that we can make sure we've got things covered for the sorts of things that you're doing. As far as barriers go, probably one of the biggest ones is getting the word out. It's not so much a barrier as it's just a relatively slow process of getting the word out that there are tools available for this sort of thing. Where there's a regulatory process going on, such as in California, the word is starting to get out because there's getting to be a need for assessment of the greenhouse gas balance of practices, and in particular where that might fit into an income stream, an added income stream to a grower to help them with with their on-farm operations. So, but helping to get the word out would be really helpful.
Great, and then if you could speak real quick to our second question on, and I think you probably have answered this in different ways, but how do you envision Comet Farm helping farmers to improve regenerative agriculture? Do you see it mostly as kind of a decision support tool, being able to envision different scenarios, that kind of thing?
Yeah, really, it's a conservation planning scenario tool. It's all about giving growers the opportunity to look at what their practices are and be able to assess, okay, your typical grower has a lot of different things that they're trying to balance when they make decisions about how they're going to manage their land. What sorts of crops am I going to grow next year? What's going to be my source for added nutrients? There's cost issues, there's water quality issues, there's issues related to humane management of livestock, all kinds of different things that are interplaying, and what we're trying to do is give users the opportunity to assess the greenhouse gas mitigation potential of those different management scenarios, different practices at the same time, so that they can run scenarios about changes in tillage or shifting from, say, for example, synthetic fertilizers to organic sources like manure or compost. And at the same time, also with that, they can assess what the potential benefits for the greenhouse gases are. They also may be able to use those numbers that come out of the tool to potentially tie into an income stream, say to work with either an aggregator or a co-op that's looking, for example, at trying to partner with an agency that's trying to fund mitigation actions. So they can get assessment of what potential payments might be based on a fixed cost or a fixed price for carbon. Does that answer your question?
Yes, that's great. Yeah. Well, thank you, Mark. And I think now we'll try and open it up to everybody. So if anybody either on the Hangout or who is just viewing on the event page has questions, feel free to chime in. Folks that are on the event page, I think there is a question-answer app within the kind of broadcast interface, and we'll be able to see your questions through that. So with that, I'll open up the floor.
Yeah, Mark, this is Dorn talking, and that was really fantastic. Thank you so much for presenting. That was just the sort of thing that I think this group was looking for, and I know I was looking for, to get a better understanding of a step-by-step process, and with the hopeful outcome that we can understand how your tools will interact with some of the other tools that will be presented and projects coming up. I know in particular when I present on FarmOS in a couple weeks, I can really focus on a couple areas that you were highlighting around practices and activities, and particular fields that we may or may not be highlighting that would help provide an easier way to make sure that our data lines up.
Excellent.
I was, as you were talking, I was imagining where we could put little asterisks that say, fill this out if you want to be able to share this with environmental models like Comet Farm or something along those lines.
That sounds great.
I was also, it also occurred to me that the open layer, so I just highlighted that where we immediately line up as far as the data entry is we're also using open layers, so that should be pretty straightforward, and you've already implemented some capabilities that we haven't yet. So that was pretty cool to see. And then obviously we have activities that line up, and the other area that we may be able to overlap is on the climate data, where it's not calculated. We may be able to have some actual sort of more localized data to feed in as well.
Okay, great. Yeah, that's because local information, site-specific information, particularly with regards to climate and soils, really can improve the model.
The other question that I had was around where you're just starting to get into sort of management decision support, the ability to be able to customize some of that output. The output that you presented here was climate focused as opposed to soils focused, and I think from the Farm OS perspective, we'd probably want to take probably the same data, but be looking at it from some of the less the emissions and more sort of the soil side of it. So we're looking at sort of the carbon capture effect and what that's going to have to do with water capacity or other management goals like that are a little bit more short term. And I mean, I think it's really exciting to be able to start to think about tapping into the environmental markets on the climate side.
Mm-hmm.
But I think it'd be great to be able to sort of merge those together, because they're two sides of the same coin, it seems like.
You know, and that's a really great point, and other people have raised that issue with us as well, and so we have a new version of the tool which we're expecting to release in the next 2 weeks in sort of a beta release, if you will, that'll be available for you all and anybody else who's interested to come in and use. And we're trying to address that particular issue here, where on the report page we'll be able to show the users how much of the CO2 change is due to uptake in soil carbon. So it'll be essentially a direct feedback to, okay, well, I increased my soil organic matter by 0.25% through this, or these sorts of things, and of course all the other benefits that come from that cascade from improvements, increases in soil organic matter. The person can extrapolate to that.
Yeah.
So a preview of a coming attraction there.
Fantastic. That's great to hear.
Hi, Mark. Abe, thanks for the presentation. That's great. I am curious about instances where heavily monitored farms with a baseline doing some combination, total management system, achieving change over time with quantification, how instances like that might affect the modeling. Are there opportunities, because I understand that you've done this mostly with data from row cropping in the Midwest and so forth, but say there was a grazer in Georgia or New York or California who did a whole bunch and seemed to be improving soil and water dynamics and carbon sequestration ultimately. Could that influence the models?
Yeah, that's a really great point. And so, for example, somebody who's taking a really integrative approach, they're going out and they're really checking out their pastures and the sorts of stuff I hear other people in this group talking about, where you're using multiple species and you're trying to integrate other sorts of practices to try and build soil health, as opposed to just, as many producers end up doing by default, they end up mining resources. And yes, so in particular, what we find is that a lot of grazers, for example, they'll adjust their offtake based on what their pasture conditions currently are, and so they'll adjust the amount of livestock on a particular pasture at a particular time to try and optimize for the amount of feed that's actually available. And the tool is designed for users to be able to do that sort of thing. And now that is not in the current production version, but that is in the new version that we're working on right now, so that users can adjust on a year-by-year basis how much offtake is actually happening on their pasture, and also try and integrate in the feedback loops where they might be producing compost, or they might be composting manure from an associated operation, such as a dairy nearby, or maybe whatever, and trying to introduce those feedback loops for other sorts of organic matter inputs back into the soil. Trying to get those in. So the model, now there is a question as to how well the model is able to integrate that, and it does a pretty good job, but it's not perfect. Unfortunately, that's one of the things that we find with dynamic models, is that we can get, I think, a pretty good general sense for how integrated practices like that can improve soil conditions, but it's not necessarily a precise answer. It's an accurate one, but in some conditions it may not be very precise. But it definitely shows the trend that the growers are likely to be seeing. So,
Mark, if it occurs to me that with the National Soil Health Initiative, we'll be collecting a lot more soils data, a lot more diverse types of soils data. And a lot of that isn't right now part of the standard data entry, but if we're already recording it and we have some actual results based on management practices, how would you see the process of pulling that kind of data into this system for changing some assumptions on, say, same practices, different soil health?
Mm-hmm. That's a really good point, and other people have raised that issue, particularly within the NRCS, and it's a topic we're going to be taking up here in the next, probably this summer. We've got an initiative planned to start to discuss that with our NRCS partners, and likely be drawing in people like yourselves and others to help advise us on how we ought to do that.
Fantastic. Well, I think I think that it's a great role for this group to help facilitate that conversation.
Yeah, it would be.
Great.
Yeah, agreed. Great. Well, we're fairly close to the 4 o'clock mark. Wondering if anyone has any last-minute questions or anything like that. You know, I'm looking at our kind of agenda we had come up with, and it's one of the last points was discuss ideas on how to work on incorporating Comet Farm and generate collaboration. But I feel like we have covered that fairly well in this conversation here. So.
Do we want to mention what's some of the other talks that are coming up in the next couple of weeks?
Absolutely. Yeah, next week, let me pull up the calendar here.
I think we have Amanda going.
Yes.
And unfortunately, her audio is off for today, so we're going to have to, but she'll be presenting the project drawdown, and I think there's a link on the calendar for you all to take a look at what she'll be presenting on.
Yes, yep, and then after that will be you with FarmOS, Dorn,
Yeah.
on the 21st, 28th, Bianca Mobius from, is that USDA NRCS?
Yeah, I will confirm that. There's a question mark there, but if it's not that, it will be shortly after that.
Great. And then a few others that are kind of in the hopper there, but it will be same time, Tuesdays at 3 p.m. We're going to try and do it every week for the next, oh gosh, about 6 or 7 weeks or so, and see what we can generate. There should be a link too on this event page to our new website that we've put together that we will be posting presentations, the video of this presentation, so you can hear the audio and see Mark's slides and the tool again, as well as it also will be the home for our calendar for this series and stuff like that, and any other kind of information. So, yep, there we go. Doran just shared it. So. Great. So with that, I think we'll maybe wrap up the broadcast. If folks wanted to, that are in the Hangout, wanted to hang out for a little bit longer and discuss a few more things, we can do that. But with that, I think we will go off air.
Thank you, everybody.
Thank you.
Thank you so much.
Yeah.
I'll stay on for a couple minutes here.
Sure.
Oh, great. Thanks, Mark.
All right.